This is a factoring review of all types of factoring that you'll need in pre-calculus. So I have some headings. I have some different types of factoring. Some you've seen, some maybe you haven't ever seen. We're going to do at the end of this, we're going to do one called the sum and difference of cubes. Some of you maybe have never seen the sum and difference of cubes before. So I'm just going to get right into it. I encourage you to pause the video as we go through this and take whatever notes that you need. This math that I'm going to do here will be buried inside of the problems that you're going to need to do. So if you can't do this math, it makes the next section pretty hard. So let's go. First of all, there's GCF factoring. GCF factoring stands for the greatest common factor, and GCF factoring is one where you have some type of polynomial and you're trying to look for terms that you can pull out of the polynomial. So I have one here. Got my sheet here. I have 5a squared b cubed minus 15ab squared plus 25a5b6. Okay, and we look for terms we can pull out. This is the trinomial, and it's not probably factorable with any other method except for can I pull a term out. And I notice constants are 5, 15, and 25, so I can pull out a 5. I have a's in every term, and the rule is you pull out the a with the smallest exponent. So I see a squared, I see an a, and I see an a5. That one has the smallest exponent, so I can pull a single a out. And then I see b's in all terms also, so I can pull b squared, and b6 out. So b squared is the smallest one, so I'll pull out a b squared. And then I decide, after I pull it out in front, go back through and I decide what's left over. So I pulled 5 out of 5, there's a 1 there. I pulled a out of a squared, that means there's an a left over. And I pulled b squared out of b cubed, that means there's a single b left over. Minus, I pulled 5 out of 15, there's a 3 left over. A out of a, there's a 1 there, I don't have to write it. B squared out of b squared, there's another 1 there that I don't have to write it. 3 times 1 times 1, I'll just leave it 3. Plus 5 out of 25, there's a 5 left over. A out of a5 is a4. B squared out of b6 is b4. And I factored out my GCF. I pulled out my greatest common factor. That's GCF factoring. You'll have to do that. The second type of factoring is trinomial factoring, and there's a lot of techniques to do this, depending on where you're at and what teacher you've had for some of your algebra 2 background. We do a method called Xwing factoring. I'll show you that real quick. Xwing factoring is x squared plus 11x plus 10. And what Xwing factoring entails is it takes this trinomial and it breaks it up into the 2 binomials that you would get if you FOILed those binomials out to get back to this trinomial. So we do Xwing, and we put an x here. And you look at factors of this term right here. So there's my x squared term, there's a 1 here. So I think to myself, what times what is going to multiply to 1? Well, there's only one option. It's 1 and 1. And then I look at my n term, and my n term is 10. And I think, what times what is 10? And it's 5 and 2. I could use 5 times 2. Or I could use 1 times 10. And I just think, what multiplies up to that 10? And my numbers, I'm going to try 5. It's usually the 2 closest to each other, 5 and 2. And then I multiply across. 2 times 1 is 2. And across, 5 times 1 is 5. Then I add those 2 numbers up. 2 plus 5 is 7. And I see that middle term, and I see if it equals the middle term there, and it doesn't. That must have meant 5 and 2 are the wrong 2 numbers. So I try again. I'm going to try 1 and 10. 1 times 10 is 10. 1 times 1 is 1. I add those up, and I get 11. And that 11 is that 11 middle term. Now, as you get good at these, you should be able to look at those and think, oh, 5 and 2, or 1, oh, it must be 1 and 10 to get me to 11. So you don't have to go through the whole guess and check process. But I got it. I got 11 in my middle term. I got 11 there. And your 2 binomials are the 2 binomials you would get with those 2 values as your coefficients. So it becomes 1x plus 1, or x plus 1, times 1x plus 10, or x plus 10. And you should probably FOIL it, at least in your head, just to see if you got the right answer. So I got x squared, I got 10x, and 1x is 11x, and 1 times 10 is 10, and I got it. I would like you guys to try x squared minus 11x, x squared minus 11x plus 24. Pause the video and see if you can Xwing factor that, or use really whatever method that you want to factor that. Okay, here we go. Factors of 1 are 1 and 1. Factors of 24, it's either 6 and 4 or 8 and 3. And I think to myself, oh, what's going to get me to negative 11? Probably a negative 8 and a negative 3 will get me to negative 11. Let's try it. Negative 8, negative 3. 1 times negative 8 is negative 8. 1 times negative 3 is negative 3. And that's negative 11. So let's try it now. 1x minus 8, 1x minus 3, x squared, negative 3x, negative 8x is negative 11x, negative 8 times negative 3 is positive 24, and I got it. Okay, those were the easy ones. Now we're going to Xwing it with a leading coefficient. Xwing it with a leading coefficient. So I'm going to go 4x squared, and it's the same process. I don't have a different x squared plus 4x. I think it's minus 3 is the one that I'm going to do. Yeah, it's not a different process, luckily. It's the same process for leading coefficient. We just got a number in front, so we have to make some decisions. So what multiplies to 4? 2 and 2, or 4 and 1? I'm just going to tell you, usually you start with the two closest to each other. I'm going to start with 2 and 2. Negative 3. Well, it's a 3 and a negative 1, or a negative 1 and a 3, however you want to manipulate the minus sign. But it's going to be a 3. I'll try that. I'll try 3 and negative 1. And let's see what happens. So I got 3 times 2 is 6. 2 times negative 1 is negative 2. That's 4. So I got 4 as my term, and oh, looks like I got it already. Let's do it. 2x, we'll go over here. 2x plus 3 times 2x minus 1, and again, I'm still going to check it. 4x squared, negative 2x plus 6x is plus 4x minus 3. I got it. Here's the one I'd like you to try. 2x squared. 2x squared plus x minus 28. Hit pause. You try that one. Okay. Xwing. Factors of 2 are 2 and 1. Factors of 28 are 2 and 14, or 7 and 4, or 1 and 28. I'm going to try the closest two to each other. I'm going to try a 7 and a 4, and one of them's got to be negative. I'll try that way. I don't know. So that's 14, and that's negative 4, and that's 10, but that's not my middle term. So what you can do is you can switch the order of your 7 and your 4. I had 4 and 7. I'm going to try 7 and 4, and I'll make this one my negative 1 here. Let's see how that works. So that's 8, and that's negative 7, and that's 1. And 1 is my coefficient of the x, so I think I have it. 2x minus 7, and 1x plus 4. Let's see if we have it. 2x squared. 8x minus 7x is plus 1x. Negative 7 and positive 4 is negative 28. I got it. Looks like that. And that's 4 Xwing examples, 2 that didn't have a leading coefficient. Leading coefficient was 1, and then 2 where the leading coefficient was something other than 1. And these are the really hard ones, the trinomials where there's a weird, funky leading coefficient there. All right, next one, next factoring type is called dots. It stands for the difference of two squares, the difference of two, and sometimes I say difference of two perfect squares. But there's an acronym, I call it dots. And the type of problem that you get, and I'm probably going to do 3 of these, it's just like x squared minus 4. So really it's a trinomial without that middle term right there, without that term. And it takes a prescribed thing. If this is a perfect square, which means I can think of two numbers that, or two things that multiply together to give me that, the same thing. And so like for instance, x times x is x squared, the x is the same. And 2 times 2 is 4. There's a minus sign. It's called the difference of squares. So it's easy to factor. X and x, 2 and 2, and plus and minus. And it's just, if those are the difference of squares, I mean, that's it. Watch what happens. We have x squared, and here's the difference of two perfect squares. Here's where it comes in. You got minus 2x plus 2x. The minus 2x plus 2x. I might write this one out. I'm going to go x squared when I FOIL, minus 2x plus 2x. And then 2 times negative 2 is negative 4. And what happens when you factor this in, these two terms, they cancel out, and I'm left with x squared minus 4. That is the factored version. This is the checking to make sure it worked. So that's what we got. We got it to work. So let's try a little bit harder one. Let's go with 4x squared minus 100, and I put a leading coefficient there. So I'm going to go with 2 parentheses again. Factors of 4x squared that will be in the front spot. Well, factors of 4 are 2. Factors of x squared are x, so it's 2x and 2x. It's always plus and minus. And then 100 is 10 and 10. And I could probably also have gone back here and GCF'd out a 4 also, because I noticed I can pull out a 2 out of both of those, a 2 out of both of those, so there would have been a 4 out in front. So that works, or I could have pulled a 4 out. So another way I could have written it was originally, these two work. I could have originally said 4x squared minus 100. I'll pull out a 4. I'm left with x squared minus 25. And then that's still dots. So it's 4 times x minus 5 and x plus 5 would have been the dots version of that. So that's probably the best version of it, but this is also a dots version that works. Okay, you guys try a really hard one. 25 x to the 4th minus, it's got to be a minus sign for difference of squares, 64 y to the 8th. Press pause, see if you can do that one. Okay, here we go. 25 5 square root of 25 is 5. X to the 4th, square root of x to the 4th is x squared. Difference of squares factors into a plus and a minus. Square root of 64 is 8. 8. Square root of y to the 8th is y to the 4th. And that is fully factored in dots. Okay. 2 more types, really 3 more types, but 2 of them are kind of the same. 4-term polynomial, 4-term factor by grouping is what the term is. So we're going to have a 4-term polynomial, something like this, x cubed minus 2x squared plus 4x minus 8. And factor by grouping means I see 4 terms up there, and I'm going to take the first 2, I'm going to group them together, and I'm going to take the last 2 and I'm going to group them together. And you really want it written in this form, like the exponents decrease by 1 or decrease by whatever it is. And then within each group, you try to look for things that'll come out. So I'm going to GCF out of these 2. I'm going to pull out an x squared, because I notice I have an x cubed and an x squared, and I'm going to ask myself what's left over. Well, x squared out of x cubed leaves me with an x. I got a minus sign. And then x squared out of that, I'm left with a 2. And then I'm going to go to the second parentheses, and I'm going to pull a 4 out. And I'm left with an x. And I'm going to pull a 4 out of the 8. I'm left with a 2. And really, in order to factor by grouping, you're kind of assuming if it's 4 terms, a math teacher set this up. So a lot of times this happens, mainly because a math teacher somewhere wrote the problem and wanted this to happen. But you have the same term here. And really what you're doing is you're taking that underlying value and you're GCF factoring out in front. So you're taking that and you're pulling it out in front. So I'm taking an x minus 2 out in front. And then you're deciding, well, if I pulled x minus 2 out, what would be left over? So if I took this term right here and I pulled x minus 2 out, I would have an x squared left over. If I took this term right here and I pulled an x minus 2 out, I'd be left with a 4. And a lot of people think, oh, you pulled it out, why is there not 2 of them? Well, it's like that GCF. When you pull it out in front, there's not 2 of them there. You took this whole thing here and this whole thing and you pulled them out in front. You pulled them out of the term. So it's there, and then you're left over with x squared plus 4. Okay? Here's your problem. You guys try this one. Try x cubed minus 2x squared plus 5x minus 10. You guys try that one. Press pause and go. All right, here we go. I'm going to group like that. I have x cubed and x squared. I'm going to pull an x squared out in front. So I got the x squared out in front. I'm going to decide what's left over. Well, I have an x here. Ooh, it's a minus 2 again. What do you know? So I pull the x there. X squared out, it leaves with an x. X squared out of that is a 2. I have a 5 and a 10. I'm going to pull a 5 out. If I pull a 5 out of that, I'm left with x. A 5 out of that minus 2. I'm going to take x minus 2 and I'm going to pull x minus 2 out in front. X minus 2 comes out in front. I'm left with x squared plus 5. And that's a factor by grouping one. All right, last one is one that, or last 2 types, I guess. They're kind of the same. And it's 2 types that don't get dealt with a ton, but we do deal with them here, and it is a factoring technique that you need to know. And it's called sum and difference of cubes, and there's a set way of doing this. It's like almost like a little formula that you do, and I might write out the formula as we go through. So sum of cubes, I'm going to take x cubed plus 8. And the sum of cubes basically means the first term is a cube. One number times itself to get that. So x times x times x is x cubed. And the second number is a cube. So we have 8, and that's 2 times 2 times 2. So when you're doing sum and difference of cubes, you're looking for 2 values in these spots that are cubes. And it's set in stone. I mean, the sum and it factors into a binomial and a trinomial. That's just how it factors. And this value right here is a cube root. The sign right here is the same. And then this value right here is going to be a cube root. So the cube root of x cubed is x. The sign is the same. And then the cube root of 8 is 2. X times x times x is x cubed. 2 times 2 times 2 is 8. That's the first parentheses. Cube root, same sign, cube root. Okay? Here, you square first binomial term. So that value right there, that x, it gets squared and it becomes x squared. You always change the sign on this term. So you change the sign, the plus becomes a minus, and then you multiply these 2 terms together and put it here. So you take 2 times x, and I get 2x. This is multiply terms. Okay, so and then and we'll do a bunch of these. So don't worry if you're swimming right now. So that last sign is always plus. So this is a plus sign. And then this spot right here is square second term. Square second term of the binomial. So 2 squared is 4. Your answer is this big long thing here. Okay, and what it is, and if you want to test me out here, this would be awesome. You can go back and test me out. But if I took that and I folded it times that, I get back to x cubed plus 8. That right there factors into that. So it goes cube root, same sign, cube root. Square the first term, change the sign, multiply the two together, always plus, square the last term. And that right there, it's the same as down here. And we're going to do this 3 more times. So hopefully you have good notes on that, and you can pause it or rewind it or do whatever. But let's do another one. I'm going to need some room here, so I'm going to erase this. But I'll help you do it. So let's go with 8x cubed plus 1. Go with 8x cubed plus 1. And that's the sum of cubes, because 8's a cube, x is a cube, and 1 times 1 times 1 is 1. So here we go. We're going to go. Cube root of 8 is 2. Cube root of x cubed is x. Cube root, same sign, cube root. That's the binomial. The trinomial is square that term, 4x squared. Change the sign, minus. Multiply these two together, 2x. Always plus, plus. Square the last term, 1. And I got it. And you could FOIL that. Another way to check to see if we did this right, you could plug this in y1 in Desmos, you could plug this in y2 in Desmos, and you could see if the two graphs are right on top of each other. And if they are, we know we graphed it right. All right, that's sum of cubes. Difference of cubes is basically the same thing, except there's a minus sign in between them. So we'll look at that. We'll go x cubed minus 64. You know what? Let's put 2 of them here in the same spot, and we'll see if we can do this. X cubed minus 64, and the pattern is the same. Cube root, same sign, cube root. Square the first term, change the sign, multiply the two together, always plus, square the last term. All right, so here we go. Cube root, same sign, cube root. 4 times 4 is 16, times 4 is 64. Cube root of 64 is 4. Cube root, same sign, cube root. Okay? Square the first term, x squared. Change the sign, plus. Multiply the two together, 4x. Always plus, plus. Square the last term, 16. And we have it. Difference of cubes. All right, let's see if you can do this. I'm going to give you a hard one. See if you can get through it. 125x cubed minus 216. I'm telling you, all of those are cubes. Press pause and see if you can do it. Okay, it's difference of cubes. We know it's going to be a binomial and a trinomial. The cube root of 125, 5 times 5 times 5 is 125, so I put a 5 there. Cube root of x cubed is x. And 6 times 6 times 6 is 216. I think that's right. 6 times 6 times 6 is 216, so that's right. So it's 5x minus 6. Okay. Cube root, same sign, cube root. Okay, square the first term. So 5x, all of that squared will be 25x squared. Change the sign. Multiply the two together, 30x. Always plus, and square the last term, 36. So that is a full-out factoring techniques that you're going to need to use for pre-calculus, and specifically when we do limits here, we're going to need to be able to algebraically evaluate limits. We will take things like this and be able to factor them, and that'll make our life a lot easier. So good job. Have a great day.